Okay, so we're going to talk about functions. So, what is a function? A function is a piece of code which is only run when it's called. So, what I mean by that is when we write a function and we call it declaring a function. So, when we declare a function, we use the def keyword and then we can declare the function. So, we give it a name, we give it some parentheses, and we give it a colon. And that colon will say that we need to indent, and everything that's indented after this belongs to that function. So in here, I can say hello from a function. So when I say that this is only being run when it's called, if I now execute this Python file, you'll see down here in the console that the file is being run with this command here, and then it's immediately just asking us for our next terminal input, which means that there was nothing coming out of this script. This print line here was never ran. And the reason for that is if we pretend that we are the Python interpreter, we are the thing that's running the code, we're going to go through, so ignore this, that's a comment, nothing on line 2, nothing on line 3, then we say line number 4, okay, we're defining a function, it's called my underscore function, and then if this runs, we're going to do this, but now we're going to move on, we're not doing any of that, we're just saying, okay, I know this exists, let's continue. But it's not being told to do anything, so that's where we have to call it. So if I type the name correctly, well, autocomplete does it for me. So now down here, I can call the function by running my underscore function. And now when I run this code, we see here, hello from a function. And that's because what the interpreter is doing is it's going, right, nothing, nothing, nothing. Oh, we've defined a function called my function, and if this is ran, I'm going to do this, but I'm not going to do it yet. I'm just going to remember that this exists. And then it's going right, line 6, nothing, line 7, we're calling that function. What does that do again? Let's jump back here. We're going to print hello from a function, and then it's going to continue what it was doing from line 7. So to further illustrate this, we can do it a few times. And here, as you might expect, when I run this, we're going to see hello from a function 3 times, because every time this is being ran, the interpreter is jumping back up to where we declared it, and it's going to run the code. Now, something to bear in mind with functions is you can only call them after they've been declared. So as you can see here, if I have one attempted call before and one after, this here says, my function is not defined. And then here we're defining it. And now here we know what it is. So there's always that sequential pattern in Python. So whenever you have functions, you want to declare them usually towards the top of your file before any actual sequential code is being added. So if we create like a static function like this, something which always does the same thing, generally that's not super useful. And that's because we might want to change what the function does depending on certain variables. Or we might want it to do certain things with pieces of data. So how do we pass data to functions? We use arguments. So if I go back up to my function here, and within the parentheses, I'm going to put argument. Okay. Actually, no, that's not clear. Let's be more clear. Let's be more clear. Let's put output data. Okay. And now this time, what I'm going to do is I'm going to, instead of printing a string that I declare here, I'm going to print output data. So now, because we know how this works, I'm going to do my function. And what do you think is going to happen here when I run it? Well, if we put ourselves in the shoes of the interpreter again, so jumping ahead to line 4, we're saying, right, we've defined a function called my function. And when this is ran, I should also be given something that I'm going to call output data. Now this can be anything, but whatever data I get given here, I'm going to remember it by this variable name. And then I'm going to use that data and I'm going to run print with it. Okay. So if I run this, you'll see we get an error. So we get a type error, and that is that my function is missing one required positional argument. And this is called output data. So that's saying, hey, you're calling this function, but I'm expecting some data to be able to work, so I can't do what I'm meant to do. So can you please give me some instruction, some data, some arguments? So here I'm going to say hello from a function, and this time it should work correctly, where we're calling the function, we're giving it a string that says hello from a function, and then from here on the function's going to remember this string as this variable name. So then you can see when we print it, that's how this here should end up in our terminal. Exactly like that. So that's how we give data to a function, and we can give more than one piece of data. We can say data 1, data 2, data 3. So then what I can do here is I can print these, and I won't hang on this too long because I think this probably should make a good bit of sense now. But there we go. So this time, when I run my function, the first piece of data is a string that says hello from a function. The second piece of data is the integer 1, and the third piece is the integer 2. So when this runs, I would expect 3 prints to be called. So that means there'll be 3 separate logs in the console. One saying hello from a function, and then 1, and then 2. So when I run this, you can see that's happening just like that. So we can pass as many arguments as we want to a function. Of course, the asterisk there is you still want to make it easy to digest where possible. Functions, generally, you want to have them do one specific task. You don't want a function to do loads of different things. You want to really break up and isolate your code. So a good example use case for a function here, in my opinion, is sanitizing user inputs and validating user inputs. And what I mean by that is, let's say that I have a script, and okay, so let's say we want to get the user input. Okay, so that's going to be input, and I'm going to say give me a number, and then I'm going to say print string of user input plus and then string user input plus 1. Okay, so what this is going to do is this is going to ask the user to provide them a number, and then we're going to assign the number to the user input. And then I'm going to run a print statement, and on here I'm going to first print the string of the input they've given us, because I'm expecting an integer. So actually this doesn't need to be wrapped, but it's fine. Actually, sorry, I did miss a bit. Let's wrap this in an integer call. Okay, that makes more sense. So we are getting this as an integer now. So this is an integer. So that's why I need to convert it to a string. And then I'm saying the number that they've given us plus 1 equals, and then I want to output that as a string. So I'm doing this actual math within the string function, and then this should give us our statement. So if I run this and I give it the number 2, it says 2 plus 1 equals 3. So let's run it again, and let's say 1. 1 plus 1 equals 2. So you can see how that works. But now let's run it, and I'm going to say foo. And we straight away get an error, and that's because this call here is trying to convert the string foo into a number, into an integer, which it can't do because foo it's a string. There's no way to interpret that as a whole integer. So the way that we would get around this generally would be to do like a try except block. So I would say while user input, well, first I'd probably say user input, user input equals none. So I'll first declare it so it's accessible, and I'll say while user input, or while type of user input does not equal an integer, then I will take the user's input so I can reuse this. Except now I'm going to use a try block to say we're going to try and run this code here, but it's very possible we could get an error. And if I get this specific error, so I'm going to say try except, and I can see here that the error we're going to get is a value error. So try, I need to get rid of that capitalization, except value error. And then here I'm just going to And I'll print and I'll say, please provide only numbers. Okay. So let me break this down. So first we're declaring a variable, it's called user input, and I'm assigning it to none. And the reason I'm declaring it first is because I want to use the value of this as the condition for whether our loop should keep running. Okay. So as you can see, I'm testing the type of this value, and right now the type should be none. So that means the type is not an integer. Okay, so as long as this is not an integer, we're going to keep looping. So we need to somehow update this and make sure this can become an integer to break our loop. So that's where we're doing this user input that we had before, but this time it's indented within a try block. So we're going to say try and do this, except if we get this specific error, this value error, which we can see in our console here, value error, that's the type of error we get if you pass something that can't be converted to an integer to this int function. So except if we get a value error instead, I want to print this statement, and then automatically we're going to go right back to the beginning, because currently user input still won't be an integer because this code failed. And then only when this becomes an integer, so only when this line successfully runs, our loop's going to break, and then we can move on to our print statement. So let's try this again. Give me a number. So 3. That works great. 3 plus 1 equals 4. So you can see it still works. As soon as this got assigned to an integer, this loop broke, and we went straight down here. So that's perfect. So let's run it again. And this time I'm going to say foo. And just as we were hoping, it says, please provide only numbers. So that's perfect. But now let's say that I want to get user input 1 and user input 2. So without a function, I would have to copy and paste this code and run this multiple times, and that's not what we want to do. We want to write as little code as possible. So I'm going to define a function, and I'm going to do what we call extracting this logic into a reusable function. So I'm going to say define, and I'm going to say get. I'm going to say input integer, input int. Let's do input int so that the naming convention matches int. And this is nice and clear, I think, because essentially this is we're using the input function, we're converting it to an int, so this input int makes a lot of sense to me. So input int, and then what I'll do is I'm going to indent all of this code. So in VS Code, what's really great is you can highlight sections of code, and then you can use the tab, and then you can hold shift and press tab to bring it back the other way. So you can save yourself some headaches. So input int, so all this code is going to run within this section. And now what we'll do instead is we'll say user input 1, and I'm going to say that will equal input int. Okay, I don't need to provide any arguments because we don't need to know any, we don't need to change the nature of this code. This code should do what it's supposed to do. We don't need to give it anything to change that behavior. So we're just going to assign this variable to be this function. And then we're going to print. And this time what I'll do is I'll just change these out to user input 1. I'll add some spaces there so that's nice and easy to read. And what do you think will happen here? And this is a bit of a trick question. It is going to fail to run, but I'll tell you why. So if I try and run this, you see it says give me a number. Great. So I'm going to give it the number 2. So what's our error here? So let's pretend we're the interpreter again. So from the top here we go, okay, we've defined input int, this function called input int. I won't go over what it does, we've already done that, but we know this now exists. So here we're saying the user input 1 equals input int. So that is trying to assign it to a value that is given back to the user. That's given back to the user from the function, sorry, I should say. So if we read the error, unsupported operand type for plus, so we're trying to add together a non-type and an integer. So that means that this is equating, whatever this is meant to be giving us back, it's giving us nothing. That's correct, it's not giving us anything, because I'm assigning this variable within the scope of this function, but I'm not giving it back to you at the end. So what I need to do is outside of the loop, but still within the function itself, I need to use a new keyword called return. So return user input. Okay, so now if I run this again, give me a number, 2, and you'll see it works. Now, I appreciate that can be a little bit confusing. So I'm going to do one last thing just to help showcase what this is actually doing. So there's no code down here. This is all commented out for in a second. But I'm just going to go print input. I can't type. Print input int. Okay, so all I'm going to do is print the value. So if I run this now, you'll see it says give me a number, and I'll say 1. And it prints the number 1. And that's because the value number 1 is being returned from the function. So whenever we take the value of this function running, we'll get that back. So if I comment that out, we're not returning it. We know now that no matter what happens within that function, we're getting nothing back. So, the code's doing what it's meant to do. It's saying only give me numbers. Fair enough, fair enough. At least it works. So if I give it the number 10, the value equals nothing because this isn't returning the value. So that's why we need to return it. So now this gives us a really great shortcut where we can say user input 1 equals input int. And now we can also say user input 2, and we'll do the exact same thing. So input int. So we've got this one function that's being run twice. And now instead of, I'm just going to update the print statement here to be a bit clearer, or to use our new variables. Okay. So we're going to get the first number. That has to be an integer. Same for the second one. And then we're going to say to the user that if we add these two together, that will equal. And then we're going to show them the value. So let's do it. Play. Give me a number. 1. Give me a number. 1. 1 plus 1 equals 2. Fantastic. One more time. Give me a number. 2. And let's give it number 5. Okay, that equals 7. That's correct. But there's one more thing I think we can do to improve this. If you see the prompt that we're getting, give me a number, it's not super clear. So I think that's a really great situation to use these arguments in. So I'm going to say prompt. Okay. And now instead of saying please only give me a number, I can put in here prompt. And now we'll say let's pass these this message now for each call. So let's say give me the first number and give me the second number. Okay, so give me the first number, give me the second number. So this should now be much more verbose. This should be much clearer to the user what they're being asked for. Give me the first number. Now I'm going to give you foo. Please provide only numbers. Fine, okay, I'll give you 10. Give me the second number. Bar. No, fine, I'll give you another number. Let's give it 24. Boom. 10 plus 24 equals 34. And you can see there now that we have this one reusable piece of code. We've not repeated ourselves. We are tailoring it to our use case here because we're giving it a new prompt every time to depending on what we're actually using it for. And then we're able to use it exactly how we want. So that's the superpower of functions and what it offers in terms of reusability. So if you're now thinking, when do I use functions? Well, we have an acronym in coding. The acronym is DRY, and that is don't repeat yourself. So you don't have to live and die by this book because there are, like everything in life, there are nuances. There are edge cases where this doesn't necessarily apply. But generally, if you have a piece of code that is almost like for like being reused for common functionality like this, then that is a great time to extract that functionality and to apply a drier approach to your code base. So that pretty much sums up the introduction to functions. I think this is a good demonstration to showcase their potential. And all you need to remember is you can give it as many arguments as you want. And if you want to take output from it and assign it to something else like we've done here, you have to use return. So you have to return the value from that function. That does bring to mind one last thing, which I will show you as well, which is scope. And what I mean by scope is, I mean, where are these pieces of information accessible from? Because if I go here and I say print user input, so I'm trying to print this variable, but you can see it's not defined. And that's because this function exists on its own little island. So these things here, these haven't actually ran. We can't access those here because this hasn't been executed. But then that still applies if if I call my function, I really can't spell the word input. I keep getting confused with int. But if I call my function above here, say input int blah, you can see now that user input still doesn't exist. And that's because you need to remember that everything that happens within a function stays within a function. At the same time above here, I could say 1 equals 1. So I've got a variable called 1 equal to the value 1. If I went in here and I wanted to print 1, it doesn't give me an error. But watch what happens. Let's do this. So I'm assigning 1 to the variable 1. We're declaring the function, and then we're calling the function. If I run this, it does have access to that. So that's just something to remember. And this is why keeping your functions isolated are really good. But then what's happening here? 1's down here, but it still shows it. Now it doesn't work. You have to think about it in the flow of execution. So let's go here. 1 works. Okay, I feel like I'm not making a lot of sense here. So let me just show you this. Let me just explain a little bit one more time about what's happening. The number 1, the variable number 1, is being assigned to the integer 1. And that's happening after the function, but that's okay, because it's happening before the function's running. And that's why once we actually jump up here and run this code, sequentially, if we look at it in order, 1 does exist. So that's why we can see number 1. But now if I take this and I put it below where the function's being called, and I run the same code, we get an error that 1 is not defined, because this is sequential. So while we are defining the function here, none of this code is being ran until we actually hit this statement. So that's why if we declare it before the call but after the function's declaration, it works. But just because you can doesn't mean you should. Generally, and I say generally, but to be fair, this is probably more of a biblical, yes, this is actually definitely true. If you have a function like this, you want to make sure that it can stand on its own 2 feet and that it's not dependent on anything that's outside of itself as a function. So that's why here it needs a prompt, but we give it the prompt. And it returns this data, but it provides itself with this data. It's not got any external dependencies. So just something to keep in mind as you're writing them. So that was a little bit of a tangent there at the end, but yeah, hopefully that all makes sense. But if you do have any questions, please just let me know.